Lesson 9.5, factoring the differences of squares. This one is easy. You look at it, x squared minus 9. And the giveaway is that this is a perfect square. In this case, it's x times x. And so is this. In that case, it's 3 times 3. And most important of all, you have a negative in between. And it's very simple. What it's going to be is x squared minus 9 will factor to x plus 3 and x minus 3. Now you can put it x minus 3 then x plus 3 if you want. So you could flip these back and forth. Doesn't matter at all. Why does that work? Because when you do the middle pieces of the distribution, you get positive 3x and negative 3x. And they cancel. So you end up with x squared minus 9. If you want to check, you go ahead and try and distribute it yourself. So here it is again. Perfect square, perfect square, perfect square, negative. It's going to be 2x plus 5, 2x minus 5. That's it. Try the next one on your own if you want. You can pause the recording. So, perfect square, negative, perfect square, perfect square. 6 plus 11n, 6 minus 11n. Done. Now, that would be a whole lesson for some people, but we're going to make your life a little bit more complicated by drips and drabs here. What if there's a common factor? So you look at this and you say, well, that's not a perfect square, but it's an even, and that's an even, so I can pull out a 2, and that'll leave me x to the 4th minus 81. Perfect square, perfect square. You might look at that and say, that's not a perfect square, and I'll say, yes, it is. It's x squared times x squared. That makes it a perfect square. So, x squared plus 9 and x squared minus 9. And this is the other part of the lesson. You'll say, great, I'm done. No, you're not, because this is a perfect square. So you have to keep going. 2, x squared plus 9, x plus 3, x minus 3. And just as a reminder, I'm going to put it up here. What is x squared plus 9? Doesn't equal anything. It is prime. You cannot factor it anymore. Now, this one's a little bit different. Actually, I think this is for the next lesson, so I'm not sure why it's here. So let's just cross it out. Moving on. Sorry about that. What's the solution? If you look at it, perfect square, negative, perfect square. You could do this one of two ways. Personally, I always pull it out. I think it makes my life easier. So I've pulled out the 4, and then I've factored the perfect square. And I'll get y equals negative 4 and 4. Or you could have just done 2y plus 8, 2y minus 8, and y equals negative 8 over 2, also known as negative 4, 8 over 2, also known as 4. So either way works. Personally, I like to do the first way, pull out a common factor. It's a good habit, always pull out a common factor when you can. So for example, pull out a common factor here. What's in all 4 of these? Definitely 5. So I'll pull out the 5, and actually, since now it's an actual solving problem, I'm going to divide everything by 5, and 0 divided by 5 is just 0. So I'm left with x to the 3rd plus 3x squared minus x minus 3. Looks like 4 terms, so I'm willing to bet it's a factor by grouping or solve by grouping. I can pull an x squared out, pull a negative 1, get x squared minus 1, x plus 3. A lot of people would stop right now and say, well, this is a perfect square, this is a negative, but that's a 1. 1 is also a perfect square because 1 times 1 equals 1. X plus 1, x minus 1, x plus 3. Solution, x equals negative 1, 1, negative 3. Many math teachers want you to put that in order. I don't care. Get your answers, make me happy, make yourself happy. If you want to go back and check these, you could. Let's put in 1 for a second. 5 plus 15 is 20. Minus 5 minus 15 is 0. 1 definitely works. You could check the rest. They will also work. Flipping over. Perfect squares. This is what I started to do before. See the perfect square here and a perfect square here. And a middle term. Now there is a possibility, not definite, that it's going to be 2x plus 5 times 2x plus 5. What's the difference between what we just did? Look carefully. It's a plus. It's a plus. Previously, those signs were opposite. So what you have to double check is do this term, do these terms, and these terms together. 2 times 5 is 10x. 5 times 2 is 10x. 10x plus 10x is 20x. If it works, then you're good. Now, like I just said, you got to check, so make sure it works. So look at the two below if you can. See if you can figure out. Nice news is, I don't even look at the middle term. If I see this 9, x squared, 49, 3x, since this is a negative, it's going to be negative, negative, 7y, 7y. And then I go 3 times negative 7 is negative 21, times 2, negative 42. That's good. This one, I would do 4x plus 6 times 4x plus 6. 4 times 6 is 24, plus 24 is 48. Doesn't work. This is not a perfect square. So, this one you should try on your own. Do you solve it or do you factor it? Hopefully you notice it equals 0, so yes, you do solve it. And let's see, looks like a perfect square to me. Let's see if I'm right or wrong. 3 for the 9, y for the y, negative means negative, negative. 11 for the 121. 3 times negative 11 is negative 33. Twice is negative 66, so it works. And then I just get one answer, y equals 11 thirds, because they're identical, so I don't need it. So that's all the factoring we're going to do in this unit. Now you got to take some time and get good at it. First things first, pull out the greatest common monomial factor. So if you're looking at 7x squared plus 14x equals 0, pull the 7x out. And your life just got a lot easier. If it's two terms, see if it's a difference of two squares, like a x squared minus 9, which is an x plus 3 times an x minus 3. If it's trinomial, like x squared minus x minus 12, well, you know how to factor those, so just go to it. If it's got 4 terms, it's grouping. When you're done, if you have to, solve it and check it and see if you did it right. It's kind of a hassle to put your answers back in, so you might want to just check your work process, see if that works too. Lots and lots and lots of practice problems. You need to get good at this. On the ACT test alone, you'll see at least 3 to 5 problems that involve some degree of factoring. Good luck.